Welcome to this quantum security and defense presentation. Quantum safe networks, threats, best practices, and use cases. And thank you for being a valued member of our community. Dr. Giampaolo Panariello. Giampaolo has over 30 years of experience in aerospace and telco industries. As CTO of Network Infrastructures in Nokia, today Giampaolo is responsible for thought leadership and business development in Europe, with special focus on security communications and innovative technologies, including quantum-safe networks, secure data centers, underwater communications, fiber sensing, artificial intelligence, and non-terrestrial networks. He started his career in the aerospace industry. Pioneer of LEO Satellite Constellations, he designed the payload of the Globalstar Constellation satellites. Then he moved to Telco Industry in Siemens and later in Nokia, contributing to the launch of 3G, 4G, and 5G networks in Europe. He received a doctorate degree in electronic engineering at the University of Rome, La Sapienza, and a master's in business administration. Giampaolo counts more than 50 among participations in conferences, roundtables, and publications on specialized magazines.
So, as Anna mentioned before, the idea today, the next 30 minutes, is to go through the concept of quantum safe network. Is the vision of Nokia. The undertitle is Threat, Best Practice, and Use Case. So maybe the first question that you could have is about how Nokia is talking about quantum safe network. Is a vendor of mobile phone. Let's say that we left mobile phone about 10 years ago. Now we are suppliers of network equipment. But what about quantum? So I would like to show you this slide, not to explain what is this, because you know much better than me, but just to remember that for what concerns the quantum technology 1.0 and the main technology that I summarized before, Nokia Bell Labs was inventors of transistor and also inventors of solar cells. And for what concerns quantum 2.0, Nokia Bell Labs is very active in all the three areas for what concerns research. And we as Nokia, we are very much acting with commercial product on security that we can consider part of the quantum communication. So, starting about the threats, again, you know better than me what are the threats of quantum computer on communication. I just want to show you this picture that I like it a lot. This is coming from the Deloitte Center for Financial Service and showing what is the forecast spending for defensive and offensive capability of quantum computing. So we can see a very strong asymmetry in the next future for the spending of offensive capabilities much more than defensive. And this is giving an idea of why now we have to take care of the possible attack of quantum computers on the security of our communication. So when this will come, maybe also this we already saw, this is an idea of what are the probability to have a quantum computer breaking RSA 2048 in 24 hours. There are two curves that you can see, more optimistic, more pessimistic. More or less, we are talking about probability of 50% in 15 years. So why we have to care now? I have two answers to this question. First answer, this is a press release of Google, let's say, affirmation of Google that said in February this year, that most probably quantum computers are arriving in 5 years. This was an answer to the CEO of NVIDIA that said instead that maybe 15 or 20 years is the time to have quantum computer. In parallel, there was the CEO of D-Wave that was saying, hey guys, we have already some type of quantum computer. So as you can see that maybe it's not 15 years, could be also before. But even if this will be 15, 20 years, we know that there is always this time machine of the harvest now, decrypt later concept. And now let's come to the matter of Nokia. There are some customers, let's call them customers, that came to us more than 5 years ago asking Nokia, can you help me in having a quantum safe network now? It was 2020 and also before. This is the reason why we developed a solution already 5 years ago that is able to be quantum safe, and now is evolving with the new technologies of quantum key distribution, satellite quantum key distribution, and so on. But I will show you a bit more in detail in the next slide. Let's start with the concept of best practice. What are the ones that we learn as best practice in quantum safe network? First of all, two concepts. The concept of defense in depth and the concept of crypto agility and crypto resiliency. Defense in depth is the concept that when you have a communication network, you have a multi-layer communication network, optical, MAC, and TLS, IP application, so on. Best practice for us that we always suggest to our customer is to defend more than one layer in such a way that if one layer is compromised, not the full confidentiality of the transmission is gone. The other concept is instead agility and resiliency. Crypto agility is the ability to adapt to evolving cryptography methods and threats, while the concept of crypto resiliency is the possibility to develop different type of quantum safe cryptography in order to deliver continuous protection, also in case of change of the threat coming from the attackers. So, how we see that quantum safe network have to be done, I will go very fast through this because maybe you know quite well. It's always a matter of locks and keys. For what concerns locks, it's important to use protocol like AES-256 on the user plane that is considered to be safe from the attack of a quantum computer. For what concerns the keys, there are mainly four characteristic attributes of the key: quality, strength, distribution, and rotation. Quality, true random numbers, of course, and this will be probably also the topic of the next presentation. And you can get this only with source of high entropy. Could be quantum physics, but also classical physics. The important that it's not based on math. Case strength, at least 256 bits, of course. Delivery method. There are different delivery methods that could be symmetrical, like pre-shared key or quantum key distribution, but also asymmetrical, based on math, but not the old RSA, but a family of algorithms based on post-quantum cryptography, like the one that has been standardized by NIST last August. Last one, not least the key rotation. That's very important because, this depends on the quantity of data that you are transmitting on the user plane. The faster you're going, the faster have to be the key rotation. For example, in our optical optical network quantum safe, we have a key rotation about every 2 minutes. This is the way to the receipt that we use in Nokia to get quantum safe network. And then there is the concept I mentioned you before, the concept of defense and depth. So we have different layer of communication. They are the one that are lower layer, the one in blue that are a bit more network level, then the big one that are application layer. IP is a bit in the middle. So we strongly believe, first of all, that cryptography has to be applied in more than one of these levels, because as we say, having cryptography on a zero layer, the communication is not secure. Just one level is secure, but not robust. More than one level, the communication is both secure and robust. And then what we suggest, use different type of key distribution, if you want. This is the concept I showed you before, the concept of crypto agility. So in the lower layer where the communication is established, we suggest to our customer to use symmetric crypto distribution of the key, like quantum key distribution or pre-shared key, while in the higher level, where maybe the communication is very fast, you have to send a message, you have to create a protected channel, send a message, and then you delete the channel, most probably technology based on math, like post-quantum computer, are the best for such type of application. So, based on this concept, we defined a certain number of architecture blueprints for quantum safe network. So we started more than 5 years ago with this method that is very simple, very stupid if you want, but because many digital systems are still based on this. Here the concept is to have an hardware security model that is generating a quantum key, a key that is quantum safe, and then the distribution is done manually to the encryptors. Is working, is not very elegant, and it has some problem from crypto period. Of course, you can not go very often with this manual distribution. This is the reason why 5 years ago, based push coming from our customer, we defined this second architecture that is called automated pre-shared key with symmetric distribution. The idea is to have a server, we call it Nokia 1830 Security Management Server, SMS, that is a real life network manager of a quantum key, of a key that is quantum safe. So it is able to generate the key based on the classic physics, to distribute the key on pre-authenticated channel to the encryptors, and then based on the crypto period, because he knows exactly the crypto period of the transmission, is able to rotate, to generate new key and send it to the final encryptors. As said before, this was developed about 5 years ago. We have more than 70 customers using today this solution quantum safe. It is certified not restricted, ANSI, and unfortunately I cannot disclose the name of this customer, because you can imagine what kind of customer we are speaking about. Now, how this solution is evolving to the concept introduction of the quantum key distribution. We know very well how this is working. We have a quantum layer with quantum appliance, then a quantum key management layer, and the key are distributed to the encryptors. This solution has mainly two drawbacks. So one is the stability of the quantum material transmission. That depends also on the distance. The second one is the distance. We cannot have distance larger than 70, 80 kilometers. We can use some trusted node, but then the solution is starting to be quite costly. So our idea was to integrate this quantum distribution solution with the previous architecture in this way. So now I explain you how this is working. The SMS is becoming a real orchestrator of the solution. The orchestrator is asking to the upper layer the generation of a new key based on the quantum principle, and the distribution of the quantum key distribution of the key in the other side. And then the key is going down to the encryptors. What happens if there is a problem on the quantum layer? The orchestrator understand when asked the key, understand that there is no delivery of the key, so he starts to generate the key based on the classical physics and delivering it to the encryptors, exactly like happened in the previous architecture. As soon as the orchestrator understands that the key is again available as a quantum key distribution, the responsibility to generate the key goes again at the quantum layer, and this key is delivered to the encryptors. What is the final result? So we have a solution that is working most of the time with the quantum key distribution, but with the availability typical of mission-critical telecommunication. So the file 99.999. Okay. In this way, we solve the first problem. The second problem of the distance, of course, can be solved using SAT quantum key distribution, exactly the same architecture. So using always the solution based on SMS generation of the key as backup, we can get again very high availability with very long distance. We know that satellites are not yet flying in the sky, but we are already deploying the solution, preparing the solution with some partner. We as Nokia, we are always responsible of the black box, so the encryptors and the orchestrator. For what concerns the blue box that you see on the top, we rely on partner. One of our most important partner is actually ID20. And just to show now some use case, we go in practice. What are the industries that are more interested for such type of communication? Of course, BFSI, banking, financial, and insurance, government, military, healthcare, and then all the critical infrastructure. Not only this, when we move also to the conventional CSP, also they are starting to be interested, and in particular, talking about public infrastructure, the interconnection between data centers. This is something that is going to be very relevant for quantum key, for quantum safe interconnection. And we will see some example later. Some practical cases, I will go very fast. A few months ago, this is a reference that we built with SK Broadband in Korea to protect the interconnection in hydro and nuclear power infrastructure. So this is the case of critical infrastructure done with MACsec. You remember the different layer, depends. Someone is starting from fiber, someone from MAC, some other from IP. In this case, they start with MAC. The second case here on the right is in the frame of the project QCI done in Greece, LS QCI. In this case, implemented solution of an hybrid solution, as we saw before, the third architecture with our classical method plus quantum key distribution. In this case, the protection was at fiber level or TNSEC. Other couple of examples, this again a few months ago with Turkcell, we implemented solution based on pre-shared key on IPsec. And the last one here is with Proximus, again, quantum key distribution plus hybrid classic distribution done on fiber level or TNSEC. Some picture, this is the second case that I explained before. This is for LS QCI. We implemented a connection with 3 nodes in Greece. The distance was less, of course, than 7 kilometers, was 45 kilometers. In this case, also with the ID20, in this case, with the layer of quantum key management coming from Evolution 2, we implemented also the concept of trusted node. And we simulated here DDoS attack to the quantum layer, so the not availability of the quantum key distribution. We show how our solution based on SMS was able to take the responsibility to generate the key and not losing any bit at the user plan. Again, the other case that I mentioned before, was with Proximus, similar architecture. This case was much simple with just a connection point to point between 2 data centers, again with the partnership with the config and evolution tools. In this case, we simulate the attack to the quantum layer, and now with the use of SMS, it was possible to get very high availability link, so 99.999 of availability of the network. Coming back to the matter of data center, this is another press release also this very recently with the collaboration between Nokia and Kindred to develop of new data center with putting emphasis on the data center interconnect secured by quantum safe networking. This because we know when we have artificial intelligence data network, this has to be distributed because the power of computation cannot be put all inside one data center. So part of the communication, for example, is this first data center, part in a second data center. So it's crucial to have confidentiality and integrity in the link between and among data centers. This is the reason why. This is one of the first important application on top of the government and military I mentioned before of quantum safe interconnection. And this is the interconnection between data center, in particular the data center that are elaborating the data on artificial intelligence. Just the last few slides to close my speech. This is a study that has been done by a report done by Telco Industry, April, it's about 1 year ago. So it was a survey when to deploy quantum safe network, question done to a certain number of enterprise. So you can see that more than 50% was planning to deploy quantum safe network in the next 5 years. So this means that there is a good awareness of the risk linked to the attack of the network from quantum computers. And then the other one, we are very proud of this. The question was which companies are considered leader in quantum safe network after IBM. That, of course, they are very new for what concerns mainly quantum computer. The second one was Nokia. We are very happy with this. But this is the reason is because we are working on this topic since many years, and we see that we have our friend, our people, so very well positioned in this rank. So just the last slide, what we suggest always to our customer is to implement quantum cryptography, quantum safe cryptography now. They have information running on the network that has to remain secret for a certain number of years. This is the matter of address now, decrypt later. And there are methods that are quite simple. They do not request quantum technology to be quantum safe. And the second suggestion that we give is to implement layered cryptography. So adding this protection, this encryption, different layers, such that if we have one of these layers that is compromised, not all the communication is in some way leading to the attackers. So this was last slide of my presentation, and I thank you very much for your attention. Anna.
Thank you so much. We have some questions that were coming. So if anyone has little questions, please post them. I will try to take them. So maybe from the bottom, are you using PQC for firmware updates? That's from Bill.
No, let's say that we are working at the moment at network level. So we are working at OTN-SEC, MAC-SEC, IPsec. We are not working on firmware upgrade at the moment for what concerns the PQC.
Okay, then we have, what are the standards you're following for the quantum-based systems? What about interoperability?
At the moment, what we are working when we are connecting our SMS with our encryptors. We are using a standard DCN communication, and this is the same use between quantum key management and our encryptors. So once that you can implement such type of protocols, you can work with our quantum safe network solution.
Will Nokia consider ETSI 014 as a quantum key delivery port?
We are going to consider this at the moment for the first implementation that are based on SMS. So we are using SMTV3 example, but ETSI 14 is also an option. And for sure, we will move to this direction.
And then there was also a question from Bill. For your PQC stores, are you using hardware or software?
PQC at the moment, again, we are working in the moment at lower levels, so we are working now on pre-shared key and the quantum key distribution. We are not yet implemented the PQC. This, has been standardized in last August. This will be implemented, for example, for mobile network, but based on 3GPP, this would happen not before than 2028, I believe. So for sure, when that will be the right moment, we will implement this in the best way.
And there was also a question if you could please provide more information about Nokia demo related to twisting of fiber, attempted eavesdropping.
Sorry, to the demo, twisting. No, okay, maybe to the matter of. Sorry, let me put the presentation. This was something.
Twisting of fiber.
Twisting fiber. I don't understand.
Twisting of fiber can.
Maybe
the fiber tab on a slide 30.
35, slide 31. This one.
No, 30.
30.
Yeah, here, and then there was fiber tab. Can you Sansha maybe explain the question?
Yeah.
Hi. So I think it was not slide 30, but you mentioned about Europe's first live hybrid quantum encryption key trial. So it's mentioning quantum encryption, twisting of fiber, and attempted eavesdrop.
What was simulated here?
I think next slide. Maybe next slide. Can you? Yeah, this one. So.
Okay, you hear about the simulation of okay.
Yeah, twisting of fiber.
What was done here was some simulation in case of someone was trying to attack the fiber link between DC1 and DC2 at optical layer, between the two appliances of ID Quantique, but was just a simulation, just to show that if someone is attacking the layer, so the key is not going from data center 1 to data center 2, and there is lack of key going to the encryptors. So this lack is detected by the security management module, and in this way it is able to understand that there is no key, and is able to generate the key and send it on pre-authenticated links to the encryptors, and in this way there is no lack of any bit transmitted on the user plane. This was just a simulation.
Okay. Thanks a lot.
Welcome.
Any other questions? I have a question, actually.
Sure.
No one. No one else have. I have a question about those data centers, because actually you mentioned that it's going to be for the confidential, but what I also see is that like banks are mentioning it, and a lot of big organizations that have their own data centers in different countries, they actually say that they are interested in, they looking into QKD, and they even looking again on bridging the distances with space. And sometimes I was mentioning it maybe before you joined, that I was surprised that it was between the countries when they like separated by mountains, for example, or geographically more difficult. Do you also see like that, like more further away from the most government and confidential and military applications, but those users are starting to experiment with those technologies? Or?
No, for sure, banks are one of the possible customers. You can see they put as first industry the BSSI as one of the most interested industry on quantum distribution, in general, quantum safe interconnection. The matter of distance, as you mentioned before, it is important. It's something that is important because we know that we can make trusted node, but if you make different trusted nodes, first of all, the cost of the system is growing, and then you have this trusted node that is something that has to be protected because the key is inside. For sure, the ultimate solution is with quantum key distribution via satellite. And this I can tell you that we are working with the partner. This satellite should be flying by mid of next year. And there are already a lot of customers that would like to trial the solution.
Okay.
Because really this is something that is really needed.
Is there going to be an ESA satellite, or there's going to be extra satellite?
Depends on the area of the world, because you know that this is a quite sensitive topic. So we know that we are building an ecosystem for Europe and a different ecosystem for I was saying America now. I don't know if Canada and US are the same, but anyway, this is another matter. But in another ecosystem for America, for example, in another ecosystem for Asia. So for Europe, because we are in Europe now, we are of course working also with a satellite that is sponsored by ESA.
Okay. Any other questions? It was great. I think we only thoughts on Nokia use of quantum sensors. Okay, last question before.
Quantum sensor. Let's say that there is Bell Labs that is a part of Nokia. Is the research area of Nokia that is working on sensor. We are not developing anything for commercial at the moment. If you are more interested, you can go on the website of Nokia, look in Bell Labs, and there you can see all the activity of Bell Labs on all the three areas, by the way, on quantum communication, quantum computer, and quantum sensing.
Actually, I saw about this sensing. When being in Dubai, I saw they were developing the memories for the networks that should also actually have sensing implemented to help like network optimization. Is that something that you also looking in Nokia at?
For sure, and the labs, yes, again, but we have to separate a bit between the research and commercial part. So for what concerns the quantum 2.0, for commercial, we are mainly working in the area of security. For what concerns research, we are working in all the three areas: sensing, communication, and quantum computers. Okay. So for research, for sure, we are working in different directions. You know, like the mission to the moon. Mission to the moon was something not for commercial, was something developed by the labs. So because it is an unicum. Okay, now we hope that we will make mission to the Mars, most probably. but it's not something that you can sell to other customers, like quantum safe network and so on.
Makes sense.
Thank you for watching this presentation, and thank you for being a valued member of our community.